And to give you a little insight into what TOMRA does and why we're in this space and out and about, is because we know that around the world, every minute, 1 million plastic bottles are sold. And that is enough to make really your head spin. And the plastic bottle has in many ways, as an on-the-go, one-way product, become a symbol of our throwaway society. It's very high on the social agenda because it's often littered, and also because it is a highly recyclable product that we can put back into closed loop systems. And also, you know, seeing that once you can tackle something like looking at a single-use plastic bottle and going from looking at that as waste and transforming it into a resource, that often shifts something in people's mindset and can be a trigger for a bigger behavioral change, which is why it has become quite high on the social agenda globally. Because we at TOMRA, we know that this isn't waste, this is a resource for something new. And we know that since back in 1972, when we developed the first automated reverse vending machine, which if you live in one of the 40 countries around the world that have deposit return systems, that means deposit on beverage containers, producer responsibility, where the people who produce plastic packaging put it on the market and take it back, they often use automated systems for ease and convenience for consumers. That's what an RVM, a reverse vending machine, is. It started, as you can see here, quite low tech, but still innovative in its time, taking back glass milk bottles in Norway. And TOMRA has become world leading in this field of take back systems since that time. So then, you know, for me working at TOMRA, as for many people that I have met in this space over the past years, you know, I've grown up in Norway. I've spent so much time out in the water, fishing with my granddad, spending time on the fjords, you know, spending most of my life along the coastline, really loving the sea and the ocean, and really missing these life vests because they just don't make life vests like this anymore. And I can tell you firsthand experience, having a nap in a life vest was a lot easier before. But for so many people in this space, having a close relationship to the ocean now today means that we also have a very close relationship to plastic pollution. So in 2018, TOMRA partnered with an organization called X-Expedition. X-Expedition is a series of all-women scientific voyages around the world to study and raise awareness on ocean plastic pollution and its impacts on ocean health and our own bodies. And this is as we were just setting sail, oblivious to what we were going out into from Hawaii. It was a beautiful sunny day, and you can see all 14 women of us up on deck ready to embark on an adventure. And for us, a lot of us, or at least for me as well, trying to understand the problem, because we are about to go to one of the most remote places on our planet. And then why this partnership? Why do we sail? Well, it goes back to something that my school teacher at least taught me when I was a kid, where I was sitting for tests or exams. She would always say, before you even start writing anything, make sure you read the question 3 times. Because if you don't understand the problem, your solution will not be correct. So also echoing what Bernard has been showing us today is very much about understanding the pathway and the impact of ocean plastic pollution to then do a better job on land. And this is a very multidisciplinary crew from all over the world, women coming at the problem from all different angles and all different walks of life. And sailing out, aiming for the Great Pacific Garbage Patch, we learned, or at least I learned, 2 quite tough truths. The first one was that although the Pacific Ocean is something that sounds tropical and friendly and passive, you know, docile and calm, it is not. It will not calm, at all. We had consistently worse weather than predicted. And this video is maybe like 5 a.m. in the morning. We're somewhere headed towards Canada, and we had 40 knots of wind. You can see the main sail is reefed all the way down, and we had 4 to 5 meter high waves coming around the boat. I had never sailed before I went on this trip. It was definitely steep learning curves on all fronts. And then why do we go to the Great Pacific Garbage Patch? Maybe this is not news to some of you, but this is a model developed by Nikolai Maximenko at University of Hawaii, which shows a model simulating over 10 years, if you have plastic leakage from land, how does it behave out in the ocean? Which is surprisingly complex to model because we understand we don't really understand that much about how the ocean actually moves around and how it all circulates, and how it carries and transports different things that float, such as nutrients and plastics. And what you see here is these gyres that form out in our oceans. And these form because of the rotation and the tilt of the planet and weather in ocean systems, which, you have these massive swirls where ultimately anything that floats will converge. And the biggest one of these you'll see in the center of this model, which is the North Pacific Gyre, or as it's more famously called, the Great Pacific Garbage Patch. And we all know what ocean plastic pollution looks like. We've seen hundreds, if not thousands, of pictures in media and on social media. So also I had some expectations going out there. And we know that this is the biggest and most dense ocean plastic accumulation zone on the planet. But then what does it actually look like when we get there? Because you hear garbage patch, when we're thinking about these massive islands of trash. But after having sailed for about a week and a half, we hadn't seen any ships, no other people. We're about as far from land as you can get. If anything happens, no one can come rescue us because we're that far away. It's like being on Mars, basically. Well, that's what it felt like. So what does it look like out in the Great Pacific Garbage Patch? Not what I expected. Second hard truth. This is a picture from the most dense ocean plastic accumulation zone on our planet. It is blue, it's beautiful, and in this one picture, you're seeing hundreds of thousands of fragments of microplastics. It's not so much a trash island, it's more a plastic soup. This is me holding one of the samples that we collected on board. And it is impossible for me to see with the naked eye what is plastics and what is organic matter, what is safe for fish to eat and what will be harmful to it. And this was a typical sample. We pulled up 1,000 pieces of microplastics from the surface of the ocean. And you can see it's a mix of primary microplastics, pellets, but mostly secondary microplastics that are broken down from macroplastics that have been out in the ocean, exposed to sun, wind, waves for years, if not decades. There are some crustaceans. There are also these blue jellyfish that you really don't want to touch because they sting really bad. And a wide range of types and colors of plastic. And again, this might be quite familiar to some of you working in this field, but what we also learned when we were out there is that the problem of microplastics isn't just sort of the physical obstruction if wildlife or when wildlife ingests it, but it really also carries with it this cocktail of chemical contaminants, where not only when plastic becomes brittle does it release these chemicals, but it really also, as lipophilic substances, it really adheres to the microplastics as well. So they act as these miniature sponges of persistent organic pollutants that it carries with it throughout our oceans, across normal boundaries of transport, and also into our food systems. And then the research here isn't necessarily conclusive in terms of the long-term effects, because we haven't really been studying it long enough to know for sure, but we do know that we don't want PCBs and DDTs in our system. But these chemicals, you know, the plastic is such, we don't eat the gut of the fish, or at least I don't. And then, so the plastic itself doesn't transport up through the food chain, but the chemicals that bioaccumulate in fatty tissue definitely do. And who's on top having sushi every now and then? Well, that's me. And understanding this final frontier of ocean plastic pollution, looking at where this sort of mindless consumption that we've had for decades, the final frontier of these adverse impacts where it's harming wildlife, humans, and nature, so far from the source of the problem. This is why we sail, because we have to go to that final frontier to understand and uncover what it looks like. And we have analysis showing that even the smallest change in our behavior, saying, you know, for instance, suddenly you see a plastic bottle as something of value and not, you know, not waste. We know that that kind of trigger can shift behavior on a bigger scale. So that is also why we decided to sail. And we have made this little mini documentary that I will show you guys now.
Expedition is a series of all-women's sailing voyages to different parts of the world to really study plastic pollution, the toxic impacts on our ocean, and to bring together an amazing group of women to think about how we can tackle these problems. This expedition is Expedition North Pacific. We'll be sailing from Hawaii to the North Pacific Gyre, this accumulation zone between Hawaii and Vancouver, where so much plastic ends up. What we know so far about the Great Pacific Garbage Patch is there is this accumulation zone between 20 and 40 degrees north of the equator, and in the middle of that patch, it is the most dense.
I've never been out there before, so from what I've heard, it's vast.
There are quotes, twice the size of Texas, twice the size of France.
The previous notion was that it was all microplastics and you couldn't see it. Someone's talked about an island of trash. That's not true either.
Some of the crew might be quite surprised when we get there and we realise that actually it's this very fine soup. And you often look at the water and it appears to be clean. We take the trawl through and we pull up 1,000 pieces of plastic.
I think it's hard for people to believe who haven't necessarily studied plastic pollution actually what's out there.
There's over 5 trillion fragments of plastic floating on the surface of our ocean, and there's many times that have sunk to the depths, so deep that we can't even measure.
We've got a really wide-ranging science program, so we're looking at plastics in the water on the surface. We're also looking at toxins in the water and then microplastic contamination in the air.
We have over 10 different scientific experiments going on board.
I'm going to help out the science team to do the actual sampling because that's something I really want to learn more about. But I'm also part of the expert team, coming from TOMRA and knowing what I know about how we can recycle beverage containers and keep them out of the ocean, and how we can have those land-based solutions to make sure that we sort of close the tap of litter on land while we also work out at sea.
When it comes to solutions, I really think there's no silver bullet.
There's not one solution to this problem. It has to be many different solutions all along the value chain.
The good news is that there's many things that we can be doing to tackle ocean plastic. And for me, it's all about trying to get as close to the source of the problem as we can. We know that there's so many tiny fragments of plastic in our ocean and on our coastlines. Trying to pick them up is near impossible. So trying to turn off the tap, work at the source and stop that plastic getting into the ocean in the first place is really where we need to focus our energy. We need governments working on legislation. We need industry designing new products. And we need new systems like Tomra working on deposit return schemes. And we also need individual action. We need all of us as consumers to think about our plastic consumption, shift our behaviour, and really work together to solve the problem.
It was quite a spectacular experience to have gone to a place where very few other people, maybe around 100 expeditions total, have gone to, and see this increasing accumulation of ocean plastic debris out in our oceans. And some of the final shots that you saw from the beach that we cleaned is actually from a wildlife refuge, a closed off beach. It's not accessible to the public in Hawaii, and it's one of the most polluted beaches I've ever been to. So we definitely have some work to do. And speaking of that, how do we then take these learnings and these experiences and this dedication from sea to land? You can learn more about, or we can talk more about the scientific programs that we have used or that we have collected data for with X Expedition. But one of the things that we did do with our samples is sorted them according to different protocols, to different research institutions around the world that wanted to look at different things, whether it's degradation or types or contamination on the, or biological material on the samples. But then one of the important things, because we're basically in a floating lab, so one of the ways that we're sort of taking this back on land is using an FTRI machine, which is one of my favorite toys on board the boat, where we use infrared spectroscopy, using sort of understanding of the mass of the polymer to understand, matching it towards the database to try to understand what, we can look at the color and the shape and the size, but what actually are we finding out there? And this is just a picture that I took from one of the samples that we analyzed. We can see we give it a name, and then the description is like it's from the 1 millimeter sieve, because we sift the samples through different size sieves according to, to sort them into 3 different categories according to their size. It was a black line fragment, whether it's, it can be line, it can be rope, it can be fragment film. And then the search score, which is then about an 80% hit in the database, showing us that it is probably some sort of, it's a polyamide resin, which doesn't really say much. But what we did find in these samples is around 80% of the samples that we collected in different legs around the world are actually HDPE. And what this then enables us to do, obviously you can do this in a lab at home as well, a lot more fun than doing it at sea, but this is also a policy instrument, because it's really black and white, what the plastic material that we have neglected for as long as possible before it sinks, we can tell you exactly what it might have been before it ended up out there. And then I was fortunate enough, the video that I showed you was in 2018, I was fortunate enough to sail with X Expedition again in the South Pacific, much warmer, much calmer, actually in March last year in 2020, which was exciting in itself for a lot of different reasons. And one of the islands that we sailed past is Ducie Island. This is an uninhabited atoll in the South Pacific, which was quite difficult to get to. The seas were actually too rough for us to go ashore. But the only living thing on this island that is not humans, but it's inhabited by tons of seabirds. But even here, where humans don't really have access, we see plastic pollution on the beaches. This is just a bit of a crap picture that I took from the boat. But if you look closely, you can see that there are massive fishing nets, some of them even hanging from the trees that have washed up on these beaches. The beach is just littered with buoys and fishing equipment. And there's also, to the very far left, there's some sort of machinery, it looks like, that I don't like, maybe they do something with birds, but it looks more like waste. And we know that most of it comes from land, but this is so far from a lot of our human activities that this really is the final frontier of wasted plastic material. And maybe you saw in the video that I showed you before that Emily Penn, the skipper, she jumps out into the ocean with this white orb and attaches it to this ghost net. This footage is from a year later when the vessel called Kwai actually picked up that ghost net fishing gear, and it's been circling around the North Pacific for about a year. And that NASA tracker technology was deployed to understand how it moves around our oceans, to try to understand a little bit of the oceanography of how plastic debris moves around. This one, I think it weighed in about 4 tons. So it's not just microplastics, but definitely bigger pieces as well that we can study and understand. But what this really is, though, moving into the circular economy, is wasted potential. Because in terms of collection and recycling and reuse of materials, you know, paper and steel are things that we're quite familiar with recycling. We're quite sort of attuned into the value chain of putting it back in the loop and reusing it. And the market, the aftermarket, is also quite mature and well established. But looking at plastic packaging, if we say that we collect around and we recycle around 14%, which might be a little bit generous actually, the wasted potential, the value proposition for the packaging material, not all plastics, but just packaging that we waste, is between 50 and 80 billion US dollars, according to TOMRA estimates. And if we broaden the definition of plastic wasted, we're talking maybe 170, 190 billion US dollars per year of wasted value. So one of the things that I come back to when I, as a consumer, am about to consume or take anything into my hands, yes, this is cheap, but who is it cheap for? It's cheap for me, but where is all that other wasted value going? And talking about extended producer responsibility, looking to Norway and looking to Germany, deposit return schemes are definitely a proven success because it's the perfect example of circular economy. You literally add value to something that was previously seen as waste. Looking at a plastic bottle, think of it this way. You're buying the drink, but you're just borrowing the bottle and you need to give it back. What we're seeing here is in countries that, and in terms of behavioral change, countries that don't have deposit value on beverage containers, you can expect around 40% collection rates. That doesn't mean recycling, but it means collection rates, getting it back into the loop, into the infrastructure. But the minute you add a sensible value, depending on the socioeconomic status of that or situation in that country, and the value of the material and drink as such, if you add a suitable value to that beverage container, you can get collection rates up into the high 90s, where we like to call ourselves world champions of bottle recycling in Norway, but actually the Germans are a little bit better. So it really works, and you can shift that behavior quickly. Looking at Lithuania, the return rates there, where you had 34% collection rates when you didn't have deposit on bottles. But by year 2, you're competing with countries that have had deposit and producer responsibility on bottles for decades. And this graph is a little bit complex and complicated, but this kind of shows a little bit where TOMRA sits, because TOMRA works both in waste management, in recycling industry with industrial sorting technology, but we also work with beverage container collection with our reverse vending machines. And this is just to show sort of closed loop recycling in its essence, what is needed in terms of data collection, in terms of legal oversight, and having a separate infrastructure to bring it back into the loop so that it can go back into production and distribution. Because we know the 2 things that plastic recyclers want to know. They want to know quality and they want to know supply. They want to make sure that once they set up a product line, they have the infeed that they need. And often that is the challenge, more than the actual quality of the plastic or the capabilities of the plastic as such. But what to me is interesting about this graph is if you look at the far right with the business case for plastics, if you have no real separation infrastructure and everything is commingled, all the waste goes into one bin, and the mixed plastic comes out unsorted, but still plastic as a fraction. You can look at maybe 200 euros per ton of mixed plastics. But the minute you add higher level of separation and granularity on how you set up the system, you can look at a 7-fold value increase on the market as it is for clear PP and PE. So it really is a matter of looking at what we see as waste as a resource for something new, and just being completely not willing to compromise on the fact that this needs to go into a closed loop because it doesn't make sense to waste it. And I can say that also from a personal experience, because in March, when I sailed this expedition on my second leg, we actually sailed from Easter Island, Rapa Nui, and these are the famous Moai statues on Easter Island, which are, I can talk about them for hours, I won't. They are spectacular monuments to the human resilience on that island. Much of the story about Easter Island that at least I thought I knew wasn't actually quite correct, so it's worth reading up on. But these are monuments of forefathers, of pioneer ocean voyagers who thrived and really they were sustainable before we even had a word for it, because that was the only option. This tiny speck of land, this Easter Island is about 1/10 of the size of London City. And at one point, up to 7,000 people lived here on this island. And this is a sacred site where they come to worship, where the bones and the blood of their forefathers is buried. It's a very special place to be at sunrise when everything is quiet and you can really feel these ancestors with the ocean behind them, just looking in at the island, and knowing that they have been there for many years than we can possibly understand. And then directly behind this sacred site, we decided to do just quick 5-minute beach clean. And the beach is just littered with plastic that didn't come from Easter Island. It's washing up on their beaches from somewhere else. And this is why good system design matters. Because with lack of infrastructure, take-back systems, recycling infrastructure, and accountability on land, our plastic waste shifts the burden to geographies that traditionally have been very sustainable and capable, but are now burdened with the cleanup, the collection, and the handling of material, of waste that wasn't even theirs to begin with. Because I know, having sailed, that there's no such thing as a way. When we throw something away, especially plastic, which is a magnificent material that's going to outlive us for hundreds of years, it has to go somewhere. And protecting our oceans, for those of you who now feel passionate about it the way I do, that is very much a job that starts on land. Thank you very much for your attention.